Okay, I'm back again. And here's another confidence interval problem. Suppose over the past 5 years, that's an important number, your December electric bill has been a mean of 124.32 and a standard deviation of 12.58. Assume the distribution is normal. What is the critical value for a 98% confidence interval? Well, you got to use your t-table and read that. Now, 98% confidence interval. How do we do that? You take 100% minus 98%, that leaves 2. Whatever that number is, divide in half, that leaves 1. So we look at 1% on the top, that's 0.01. And our degrees of freedom in this problem, well, n is 5, so our degrees of freedom are 4. So you go to 4 degrees of freedom and 0.01, and that intersects at 3.747. That's where that intersects. Hopefully everyone saw that. Okay, the decimal's kind of hard to read, isn't it? Okay, what is the standard error? Okay, that's a vocabulary. That's a new vocabulary word, isn't it? I have not used that one yet. Let's see, on the board I got room right here. The standard error is this right here, or in this case, that right there. So the standard error is going to be our standard deviation, 12.58 divided by the square root of our sample size. Okay, so if we do that computation, 12.58 divided by the square root of 5, we get 5.62. I'm going to round to 6. What is a 98% confidence interval? Well, what we have to do is we take our best point estimate, 124.32 plus or minus our critical value, 3.747 times our standard error, 5.626. So standard error, like I said, I'm going to put it up here. Standard error. It's either one of them. It depends. If you're doing a problem with a z critical value, that's what it is. If you're doing a problem with a t critical value, that's what the standard error is. All you're doing is whatever standard deviation you're given, you put it into the equation. Okay, so let's look at this some more. I've got, running out of space here, 124.32 plus or minus this number, 3.747 times 5.626, 21.0. And I'm going to break my, well, no, I'm not going to break my rules. If I round that up, that goes up to a 9. Okay, and they're going to keep this. This is in dollars and cents, so we got to keep it in dollars and cents. So this is going to be 124.32 plus 21.09, 145.41, 124.32 minus 21.09, 103.23. Okay. Okay, there's the confidence interval. Hopefully everyone understood where everything came from. I gave you a new vocabulary word here with standard error. I hope that you're getting very accustomed to finding your critical values using your t critical values. And that's that problem. I'll put up another one here in a minute.